Good evening, everybody, and welcome. Thank you very much for joining us here for this, our second Zoom virtual webinar since we have relaunched as our brand new Bloomsbury network. We're very pleased that you're able to join us tonight, and we can't wait to get going and give you a really interesting, fascinating presentation talk with our guest, Dr. Dimitra Pepper. My name is Nathan Taylor, and I'm a Bloomsbury Clinic patient. I have been ever since my diagnosis in June 2017, and I'm always very proud of being able to host these sorts of events and to give back a little bit to the community as thanks for the care that I get, which I'm always very grateful for. And we want to make sure this is your network, so your voice is the one that counts. So we're going to do lots and lots of feedback and stuff later on. I've got a couple of little bits and pieces to talk about before we go ahead. In terms of security, we're not collecting any data. I know you had to, you probably had to register with an email address. That's not being collected at all, I promise you that. We're not even going to get to see those email addresses. You will probably have had to join with a name as well. Feel free, if you want to change that name to a pseudonym. It shouldn't be visible at any point on screen, so don't worry about that. But again, we're not collecting that, and we don't need to know who you are. We encourage as much feedback and engagement as possible. So if you've got the Q&A function on your devices, then feel free to line up questions for Dimitra as we go along. If it's anything that occurs to you while she's presenting, then do so. Or if there's anything that she talks about in the questions later on that sparks another question with you, please do use it. You'll notice when you open the Q&A function, there is an option to say ask anonymously. If you check that, we won't even see the name that you've signed in with today. The other thing is we are recording this session. It's important for us to be able to reach as many people as possible. So if you are in any doubt as to all of that, make sure that none of your personal details are being shown. It shouldn't appear anywhere anyway, and we will be doing a sweep before we put it on YouTube, which is why it's not live there, just to sort of blank out or bleep out or snip out and pinch out any of the anything that could be identifiable, identifying data for anybody. So we're going to take your security as seriously as we possibly can. But I must stress this, first and foremost, this is an open forum, and anyone's attendance here is in no way to be taken as an indication of their HIV status in one way or the other. I happen to be HIV positive. Some of the people here will be, some of the people will not be. So no inferences can be drawn just by seeing somebody attending here. So tonight I am so excited to be able to introduce our guest panelist. It's Dr. Dimitra Pepper. She is one of the research leads at the Nuffield Department of Medicine at Oxford University, and she also works splits her time between Mortimer Market Centre and Nuffield, and we're so lucky that the Bloomsbury Clinic is attached to the Mortimer Market Centre, which is one of the preeminent HIV research centres in the world. So in terms of what's been happening, certainly over the last 18 months, but over the last 35 years or so, it's all happening at Mortimer Market Centre. And tonight is our chance to have a little peep behind the curtain and to see how the HIV research from the last few decades has fed into and helped COVID research, and how COVID research will hopefully be able to feed back into HIV and help us all out in the future. So without further ado, please, Dimitra, if you'd like to unmute yourself and switch your camera on, and welcome you. Please say big warm welcome, a virtual round of applause for Dr. Dimitra Pepper. Hello.
Oh, hi Nathan. Thank you so much for the introduction and the invitation. I am truly delighted to be part of this webinar today, and I think you said it very well. This is a forum. This is meant for people to ask questions, and I'm really going to do my very best to try and answer some of these. But what I wanted to do to begin with was just to give a very brief overview of the type of work that we do and the kind of questions that we ask, and to really be able to frame the discussion for afterwards. So
that's fascinating. That's going to be lovely. So we'll get from you an overview of everything else. But if you want to talk about your specialist subjects as well, please do, because have I got this right? So your particular field of interest is into the natural killer cell regulation of antiviral T-cell responses in the pathogenesis of HIV infection. Is that right?
That's right. Well, I am a sort of a clinician scientist, so I come from a sort of combined science and medical background. And as an immunologist, I have my favorite immune cell type, which happens to be a natural killer or NK cell. So I really started my work working in the field of hepatitis B virus infection, and then I moved into HIV. And at the moment, my group tries to understand immune responses in the context of HIV infection, but also HIV and hepatitis B virus co-infection. And then, of course, SARS-CoV-2, the virus that causes COVID-19 disease, came along. And it was an opportunity for us to be able to use some of our really exceptionally valuable samples that have been donated to us by patients and people attending Mortimer Market to be able to study the immune responses to SARS-CoV-2. So our research has evolved a little bit the last year or so. And I guess this is a great opportunity for me today to give something back and to be able to discuss some of our recent research findings of COVID-19 immunity in the setting of HIV infection. Um,
How has COVID changed what you do? I don't just mean in terms of the shift of focus, but what's its day-to-day impact been on the work that you were already doing?
Yeah, so it has a really massive impact on the non-COVID related work that we were able to perform in the lab. So during the first lockdown in March time, so all research activities stopped. So we couldn't get into the lab. All of our normal research activity and getting samples from clinic, we couldn't do that anymore because of, quite rightly, safety concerns. But at the same time, we couldn't get into the lab. So all of the work was shifted from we're a primarily wet lab based group. So we had to modify a lot of our projects, and we had to do a lot of data analysis from home. And we had a lot of very anxious PhD students that of course couldn't complete their very sensitive, time sensitive work. So we had to readjust, and we had to do a lot of online tutorials. The teaching became online. A lot of the work and the way we communicated with the group became online. And then we had to modify projects so that we can attach COVID-related elements that really gave us the opportunity to return back into the lab a little bit early, because it was deemed as a sort of a priority project. So we had to really to think on our feet, and there were some really detrimental aspects of the pandemic, but in many ways there was a silver lining in all of that, in the sense that it gave us the opportunity to extend that work into COVID-19 disease, and to be able to study immune responses in different groups with different underlying medical conditions, and that was sort of quite valuable from that point of view. We're now back in the lab, still working in a reduced capacity because of restrictions that are in place. But yeah, we're able to pick up non-COVID related projects at the moment as well. So yeah,
Well,
strange times.
I'm part of the crossover, really, aren't I? Because I'm part of the Jenna 2 study and have been ever since my diagnosis, which of course now has a slight change of focus to include COVID work within people who are living with HIV. So it's wonderful how your work has been evolving and adapting in ways you couldn't have imagined otherwise.
Yeah, no, absolutely. And the General 2 study is really a sequel of the General 1 study that was, started more than 15 years ago. And that was really an amazing cohort. And a lot of the knowledge that we have about immune responses during the early or super acute HIV infection has really has been derived from this studying these very early samples. General 2 was the sequel to that. We have been able now to add, to do an amendment and add COVID-19 elements into the work. Yeah, it's a prospective study. So we're hoping to be able to study immune responses over a period of time. And gain very valuable information about how things may change. We were not counting that a new virus, that we're going to have a pandemic, but that sort of happened. But now we're in a position to be able at least to monitor people's immune responses over a period of time and to gain that really valuable information as to how things change.
Well, I've had my second dose of the vaccine. I should be seeing you within 2 weeks to give you another armful of data for you.
And
do you want to go straight in with your presentation and give us a bit of an overview of what's going on, and then we can take some questions and answers from the floor?
That would be perfect. So let me just share my screen. Okay, just to double check, is that okay? Is that
perfect? We can see all that. Exactly right. Thank you.
Perfect. So thank you once again. It's a really great pleasure to be able to give this very short presentation today. I'm very conscious that this is an open forum and an opportunity for people to ask questions. So I'm going to try and be quite brief. But at the same time, I thought this would be an ideal opportunity for me just to go over some of the basics of the type of work that we do in the lab, in particular, the key research questions that we're asking, and also give you a brief overview of some of our recent findings of COVID-19 immunity in the setting of HIV infection, but also highlight some opportunities for people to get involved in the type of work that we do. And why is that important? Well, we really need your input to be able to refine the type of research questions that we ask, to make them really relevant and really pertinent to you. And that's really important to me as a clinician scientist. So a lot of the time people ask me, so well, what do you do? What happens to these research samples that people donate in clinic? Well, they don't fall into a black hole, I reassure you, but invariably we see participants in clinic where we recruit them at the time that they attend the normal routine clinical follow-ups, and we obtain research samples. And then these samples are transferred into my lab in Oxford, where we perform different types of really delicate, really specific immunological assays to try and understand the role of the specific immune cells in our body, in order to determine how immune responses may be inadequate or dysfunctional in the setting of disease or in the setting of HIV infection. And we do different ways of trying to characterize the immune cells, different types of, you can see here, this is a killing assay, this is a live imaging, where you can see, for instance, an NK cell coming into view here, killing a target cell by releasing these red dots, which are all the cytotoxic granules that are inside the natural killer cell. And the idea really behind of what we are trying to do is to try and identify things that are not working very well so that we can develop new targets for therapies and new targets for vaccines. And then in the long run, in the long term, be able to improve the management of our patients.
Is that mostly with a view to managing current HIV infections, or is that partly to be more helpful with understanding perhaps the nature of vaccines approaches for HIV?
Yeah, so the idea behind this, Nathan, is to give us a sort of a lot of insight into the pathogenesis of HIV infection, in particular during the various stages, from acute infection into chronic infection into treated infection. And we know that immune responses become dysfunctional, and we really want to try and identify these pathways that don't work very well, that we can try and correct in a way to try and complement current therapies that we have, or come up with better vaccine targets for a potentially both preventative vaccine, i.e. prevent HIV infection, but also a therapeutic vaccine, i.e. for people who have chronic infection as a therapy, as a vaccine for therapy. So this is the beauty of the kind of work that we do, that it gives us a very broad idea of how things work or don't work in disease and in health at various phases of infection. so that we can sort of come up with a strategy that we can apply depending on the situation, if you wish.
And of course, humanity being what it is, no one's making it easy for you, because every single human body on this planet is different and their immune systems work in different ways. Is that right?
That is correct. So there is a lot of, I mean, you're referring to what we call sort of the sort of heterogeneity in the sort of population that we study. And you're right, immune responses are very different between individuals, and that is influenced by whether you are male or female, from your ethnic background. It's influenced by your genetics, and it's influenced by the environment. So essentially, the way your immune system works, it's a sort of a combination of a lot of these things. And how people are exposed to a variety of different viruses can also shape their immune responses as we all grow older. So we have like a sort of a blueprint of various infections in the past that can shape our immune system. And that is also influenced by our genetics, the way we were sort of born, and, our tissue type, and so on and so forth. And we know that that plays a big role in the setting of HIV infection. We know that genetics can influence the course of the disease, for instance, and we know that there are particular groups of people infected with HIV that can either control better HIV, and these are the very unique individuals that we call elite controllers, that are able to control HIV in the absence of treatment. That's a very small population of people with HIV, that's less than 1%. But by studying that particular group, then we can have a really tremendous insight as to how we can, what would be the perfect environment that we can really want to recreate to be able to functionally cure HIV, if you wish.
So with elite controllers, and I guess long-term non-progressors are a slightly different category, aren't they? But is it known that it's their peculiarities of their immune system which is causing the situation within their bodies, or is it lots of different things?
It's a combination of different things. So it's their immune system, their genetics, but it's also the characteristics of the virus. So, and it's invariably a combination of a lot of these factors. So it's not, invariably this is how things work. They don't work in isolation. So there is kind of a multitude of cofactors, but certainly the immune responses and the genetics can influence how one responds to the virus. Now, how fit the virus is in terms of how well it can replicate also bears an effect on all of that.
And of course, everyone has, HIV is such a plastic and mutable virus, isn't it? And every single person seems to have different mutations and different strains, different clades, different subgroups. I can't imagine how any of the advances that have been made have been possible at all, given that set of really, really volatile and hostile circumstances for you all to be working in.
Well, we all try our best. So, but I think, what is a driving force for us is that the belief that we can actually make a difference. I think one of the, what makes our work slightly different from a lot of interventional studies is that the benefit is it's long-term, it's down the line. So, we're working on these things for many, many years. Before we can actually realize a lot of this work and are able to translate this work into something that we can put back into a patient. So we're doing a lot of the groundwork. So a lot of the work that we do in the lab is at a preclinical level, right? We're really trying to understand the mechanisms, the pathways. It's a very mechanistic type of work. And once we have a specific pathway, then we can try and move that onto the translational platform, where we can say, fine, we now have an idea, a pathway, something that we can try and correct, that we can put back and then bring back into the clinic. But there's, of course, a very long delay from getting from doing all the groundwork into doing the more sort of the preclinical stage, into sort of getting the more clinical side of things. And where I stand is more at the preclinical side of the research, where we're doing all the groundwork and we're trying to understand in sort of great detail the how the immune system works or doesn't work in health and disease, so that we can actually find ways that we can boost specific pathways, or we can try and block other pathways, for instance. But yeah, that's sort of the beauty of what we do, but there is a very it's a long process.
I think that's one of the things that the reason I was pushing those kind of questions and viewpoints is because a lot of people, we covered this in the last one with Laura Waters as
Yeah,
well. A lot of people have been saying, well, how come we've got a COVID vaccine in 1 year and we don't have an HIV vaccine in 35, 40 years now, since
yeah.
it's 40 years this year since the first cases were identified with the CDC in America. And of course, what you've just outlined is the reason. It's a very, very complex issue, and the two viruses are not the same and they don't work in the same way.
Yeah, there are different viruses. HIV is a sort of quite a unique virus that you mutates at a much, higher rate compared to COVID-19, and also the type of responses that we want to elicit with a vaccine. We haven't been able to do that over the last 20 years because we just can't elicit, very strong, what we call broadly neutralizing responses. And in fact, what we're trying to do is, we really want a vaccine that is able to elicit multiple types of responses, not just antibodies, but also T cell responses that are recognized. The issue with the HIV, and you alluded to that, is that we have different clades of the virus, different subtypes of the virus, but also the virus changes so frequently that then we can have what we call escapes. Our immune system no longer recognizes various components of the virus. That makes it a little bit more tricky. But what has been a good thing about this sort of pandemic is that now we have newer platforms that we can use and that we can sort of feed back into HIV research. And a lot of the knowledge that we've gained over the last 12 months, a lot of this work can feed back into the field of HIV. So it's bi-directional, right?
Mm.
A lot of the work that we have done, the groundwork into HIV infection, has really helped accelerate all the work in COVID-19. And it's unprecedented, the fact that we went from describing the virus to sequencing the virus to having a vaccine, actually not one vaccine, but multiple vaccines that are safe and they're efficacious to the level that they are. I mean, it's unheard of to have a vaccine with an efficacy in the 90s, right? It's really astounding. But a lot of this accelerated work has been done because a lot of the groundwork was there.
Yeah. And talk about HIV and COVID-19 leads us straight back to the slide that you've got on screen right now.
Great. So what I really wanted to focus on today is HIV and COVID-19, and in particular discuss immune responses to SARS-CoV-2 virus that causes COVID-19 disease in the setting of HIV infection. We have very limited knowledge about the relationship between HIV and COVID-19, and the questions that we have been trying to ask are whether responses to SARS-CoV-2 are suboptimal if somebody is infected with HIV infection. How long do these responses last following natural infection, but also following vaccination with COVID-19 vaccines? And in another area that I'm not really going to discuss today, but we're interested in, is what are the effects of long COVID or post-COVID sequelae in people with HIV who previously have been infected with SARS-CoV-2. We're beginning to recognize these different there's a group of symptoms that people describe having had COVID infection. We are sort of beginning to recognize this, and we really want to find out a little bit more about these symptoms and whether the immune system is somehow involved in, causing a lot of these long COVID symptoms.
And when you're talking about the responses there, that's in sort of layman's terms, that's the antibodies that we produce to fight it off. How long do they last? And are they less effective in people living with HIV?
That's absolutely right. And that really brings me on to my next slide. So I just wanted to bring a little bit of context into the immune system and the responses that I will be describing, because what is the immune system? So essentially it's our defense system. And I think it really helps if we think about our defense system as an orchestra. So this is an orchestra that is made up from very sort of different components. They all do different jobs, but they all work in tune. So they're all well coordinated and work together. And we broadly divide our immune system into two main components. So we have innate immunity, which is very quick and non-specific. So your innate cells, they cannot really tell the difference between one virus or the other virus, but they're very good at patrolling your body for any new invaders, if you wish. And they're very good at raising the alarm, telling your body that, look, there is something going on, there is a new virus here, and they can pass information on to more specialized cells. And these are cells of your adaptive cells. And these are specific. And these cells include your T cells and your B cells. So if we think about your T cells, what do? They can recognize cells that are infected with a virus, and they can kill those virally infected cells. And your B cells, on the other hand, they produce antibodies. So how antibodies work? So antibodies, they can recognize specific structures on the outside of a virus, and they can bind on that structure so that the virus can no longer gain entry into your cells and infect your cells. So they can neutralize the virus. So they can stop the virus on its tracks. And this is what we mean when we refer to neutralizing antibodies. So
they're blocking the virus from doing its job rather than killing the virus. That's the two different things.
Exactly, yeah. So this is exactly what they do, Nathan. You can see your antibodies. So if you think that this is your SARS-CoV-2 virus, and that little structure here that decorates the surface of the virus is your spike protein, your antibodies will bind to that spike protein, and they're going to form a cap. So if you think that the spike protein is like a key that unlocks the door to get into your cell, if your antibody binds onto that spike protein, it can no longer gain entry into your cell and infect your cells. So it can sort of neutralize the virus. So these are the neutralizing antibodies. Not all antibodies are neutralizing. So we have non-neutralizing antibodies, and these antibodies can decorate sometimes the surface of an infected cells, and other immune cells can come in and then deliver a kill to that infected cell. And what is super cool about your immune system is that once you have your initial exposure, and then you have your primary immune response, then your T and B cells become memory cells. So you have a small population of cells that are left behind. And what do I mean by memory? They remember that they've encountered that virus before. So the second time you're re-exposed to the same virus, in the case of SARS-CoV-2, these memory B and T cells are going to mount a much stronger and much quicker immune response to the virus. So you're going to get much higher concentration of antibodies, much stronger T cell responses. And these are going to happen much quicker. So, and essentially, this is how vaccines work. The vaccines are really trying to mimic this process of encouraging our body to make antibodies.
That's why most of the vaccines for COVID are a 2-dose regimen.
So the vaccines that we have currently approved in this country, there are 2 doses regimens. There is a vaccine that it's been trialed, it's not approved in the UK, that's a 1-dose vaccine that gives very good protection, very good responses. But the vaccines that we have currently approved in the UK, the mRNA vaccines, the Pfizer, the Moderna, and the AstraZeneca, they're 2 doses vaccines. And the way they work, they deliver the first dose is what we call the prime, so that it sort of tells your body to make these antibodies, and your second dose is the boost, where it sort of boosts these responses, and it would work like a secondary exposure, if you wish.
On that second dose, the body is saying, I know what to do with this one, and I can now flourish.
Absolutely. And this is, a representation of an antibody binding onto this spike protein that is decorating the surface of the coronavirus. And of course, current vaccines don't just help the body make antibodies, but we know they also stimulate your T cell responses, and both components, both antibodies and T cells, are important in fighting the SARS-CoV-2 virus. So the aim of is to induce herd immunity. And I know there's been a lot in the news about herd immunity, but what do we actually mean when we refer to that? So just to give you an idea, if you look into this diagram on the right hand side, you'll see that if very few people are vaccinated, shown here in green, and one person becomes infected, the disease will spread very fast because not a lot of people in the community have been vaccinated and therefore are immune to SARS-CoV-2 infection. So you can see there's going to be a very large, very quick spread of the disease. But on the other hand, if you have lots of people vaccinated, shown here in green, and somebody becomes unwell, shown here in orange, then the disease cannot spread very far. So the whole community, therefore, would stay safe. And in particular, individuals, shown here in gray, that may be more vulnerable, that may not be in a position to receive the vaccine for one reason or another, are also protected. So, and that is the reason why herd immunity via vaccination is so important. And that really brings me to the next part of my talk, describing immune responses to SARS-CoV-2 virus following natural infection in people living with HIV. So here, I'm just going to show you just a snapshot of the data. We were able to recruit 47 individuals with HIV infection from our clinic at Bloomsbury Market and the Royal Free Hospital with prior COVID-19 disease. And as a comparator arm, we recruited 35 individuals without HIV and prior exposure to COVID-19 infection. So we took research samples, including blood, and we performed a number of assays to be able to determine antibody responses, but how good also these antibodies are at neutralizing the virus. And we can do that in the lab, utilizing an assay that it's developed, and we're able to do that. Commercial antibody tests do not at the moment do not check for neutralizing antibodies. So that is the difference. Right. And we were also able to look at T-cell responses, and we used a very specific test called an ELISpot. This is an example of an ELISpot, and it is actually quite a spot-forming exercise where we stimulate your white cells with a variety of virus proteins, and then we're able to detect the responses to that individual component of the virus, but measuring the individual spots, if you wish. Mm-hmm. And what I really wanted to highlight here, that all of the participants with HIV were all well controlled on treatment. So they had an undetectable viral load. But if you look at the CD4 count, that was captured quite a range. Mm-hmm. So the median CD4 count was 560, but it ranged from 133 up to over 1,000. So here we've captured individuals that despite treatment never really fully recovered their CD4 count. And the same applies to the CD4-CD8 ratio, which is another immune parameter that we use it to really assess somebody's immune health. And what is really interesting, if you look at the two groups, people with HIV, living with HIV, they were much older compared to the HIV negative group. And we've had individuals here aged 72 and 73. And these are people who have lived with HIV for more than 30 years now. And really that is reflective of, the cohort that we have both at Bloomsbury Market at the Royal Free Hospital. So if we look at the two groups, both of the groups recovered from predominantly mild COVID-19 disease. So you can see that both the HIV positive and negative group, the vast majority, more than 70%, shown here in the pie charts in blue, recovered from mild disease. And when I refer to mild disease, I mean people who have had symptoms, although of variable duration, but they didn't need to attend, they didn't need to be hospitalized. So, and it's interesting actually looking into the symptoms that people describe, these were quite variable, and the duration was also quite variable. And it varied from a couple of days of having a bit of a sore throat and a headache to actually having a more prolonged course of disease with quite a lot of shortness of breath and fevers and really a lot of bone pain and muscle aches, but again, without requiring hospitalization. And most of our participants were recruited at around 5 months since they developed symptoms of COVID-19 disease. So that was during the first period of their lockdown, around March time last year, or almost. And just to give the summary of these results, what we were able to demonstrate was that the antibody responses, both in terms of the antibody levels, but also the neutralization responses, including T-cell responses, they were very similar in the two groups, irrespective of HIV status.
And that's really good news for all of us, isn't it? For anyone who does have HIV, who has been particularly anxious or worried over the last period, that particularly because, thankfully we were put into priority group 6 for the vaccination, which meant some of us were able to get it before our age range, which was a cause of great peace of mind. But this is great news as well, and should hopefully allow people to not start taking chances, but to not be overly anxious that their HIV status is going to have worse outcomes for them.
Absolutely, Nathan. So I think this is extremely reassuring data. And these responses, importantly, were detectable up to 7 months following this onset of COVID-19 disease. So that provides us evidence of medium-term durability of these responses, which is very similar that's irrespective of HIV status. And we now have evidence that having a pre-existing antibody response really protects to an extent against reinfection.
Right.
And also these data are reassuring from the point of view that if people develop responses to natural infection, that the chances of developing very comparable responses to vaccination are also, very high. And I'm going to show you some data demonstrating that. There is a caveat to this story, so there is a but to this story, that in some individuals with what we call incomplete immune recovery, i.e. in a small group of participants where the CD4 count hadn't completely recovered following treatment, and where in particular the CD4-CD8 ratio remained quite low, or even inverted following treatment, we found that there was a positive relationship with the T-cell responses, meaning that the healthier the immune system and the better the immune recovery after treatment, the stronger your T-cell responses are. So this is an area that we're very interested in, and clearly a lot more work has to be done to include people with a variety of CD4 counts, a variety of CD4 and CD8 ratios, a variety of different types of additional medical conditions that may influence responses to either natural infection with SARS-CoV-2 or following vaccination.
And are you able to give us any indication of what set of circumstances might lead to an incomplete immune recovery? That's to HIV treatment, isn't it?
Yeah. So one of the important things that is how advanced was the HIV at presentation.
Right.
So, for instance, participants who were a bit older, in their 70s, and were diagnosed in the early 90s, presented quite with more advanced HIV infection, and their CD4 and nadir count, and by that I mean the CD4 count at presentation, if that was quite low, then we know that that never really fully recovers with therapy. And of course, therapies, treatment earlier on during the early course of the HIV epidemic were a lot more complicated and toxic. And a lot of the damage to the immune system, therefore, has not really fully recovered. And of course, this is not applicable to somebody diagnosed with HIV relatively recently, where they still have a good CD4 count and are started on treatment. But again, that really reflects that we can't group everybody who's living with HIV in the same. It's not one group. There may be specific populations, if you wish, within that group that may be indeed more vulnerable to SARS-CoV-2 infection, or they may not have, may not be able to develop optimal responses to vaccination. And we really don't know fully the answer to that. And this is where more work and more research is required for us to be able to define what is that threshold, what is that CD4 count that really defines, we are above or below immune responses, may be better or worse, if you wish, if that makes sense.
It does, thank you.
So thinking about now immune responses following the COVID-19 vaccine, a lot of the pivotal clinical trials have included a small pool of individuals living with HIV. Nonetheless, the data that we have on safety are extremely good. There wasn't a specific safety concern in people living with HIV. And there has been a little bit more work now giving us a little bit more definition about the types of immune responses following COVID-19 vaccination. So I just wanted to highlight one recent study. This is by John Freitas' group in Oxford. This is a small sub-study of people recruited following a vaccine with the Oxford AstraZeneca. This is a small number of individuals, 54 people with HIV compared to 50 HIV negative individuals. All the participants were on treatment and had an undetectable viral load, and the CD4 count was above 350. And in fact, the median CD4 count was around 700, so a very good CD4 count. The majority of the participants were white and male. And the results demonstrated that the vaccine, as we know, is safe. And in particular, there's no difference in common reactions to the vaccine between the groups. And importantly, they didn't detect any difference in terms of antibody responses or T-cell responses between people with HIV and HIV negative individuals. Again, providing very reassuring data. So, of course, the caveat to that, because there's always a but, that we don't really know a lot about vaccine responses in people who may have CD4 counts that are low, or people who may have detectable viral load. And this is an area where we need to do more work. And this is a particular area that we are interested to really try and define immune responses, but also durability of these immune responses following various COVID-19 vaccines, in particular in individuals who may be more at risk of having severe infection, but also more at risk of having suboptimal responses to the vaccine. And this would include people with perhaps a low CD4 nadir count, a low CD4 count, a low ratio, or detectable virus. So people who are not on treatment. So there is a really urgent need to be able to establish these correlates of vaccine efficacy and really identify a group of people who may be more vulnerable and who may require a more tailored vaccine strategy, different dosing schedule, more frequent boosters, and so on and so forth. Unfortunately, I can't show you some of our preliminary data because they are currently in print, but we were able to study one very extreme case of somebody who presented with quite advanced HIV infection following 2 doses of the Pfizer vaccine. And this donor had a very high viral load, 800,000 copies, and a CD4 count of 20. And perhaps non-surprisingly, we found no responses to the Pfizer vaccine, again highlighting the importance of antiretroviral therapy and really controlling the viral load. But again, lots of questions there that we don't have the answers to, but this is an active area of research. And talking of which, I just wanted to highlight 2 studies that are currently running at Mortimer Market and the Royal Free Hospital that will hopefully allow us to gain a much better insight into the different levels of immune dysfunction and how that may influence immune responses to vaccination across a range of people with different CD4 counts, different age groups, and so on and so forth. So the first study is a general study that we've already briefly discussed, that we have now included COVID-19 elements, and there is a newer study, which is a vaccine study that requires baseline samples pre-vaccine, and that really allow us to study immune responses to COVID-19 vaccines, but also other vaccines in a much more concentrated manner, and it has a slightly different schedule for research sampling. With that in mind, and obviously if you're interested in any of these studies or taking part or having more information about them, you can always contact Mortimer Market Clinic. They will put your details, they're going to register your interest, and one of the members of the research team will be in touch with more specific information about these two studies and what they involve and so on and so forth. I don't want to take any more of your time for questions. I was just going to finish by saying a big thank you to all of you for listening, to some of you who may have been part of our study and very generously donated samples to be able for us to do this work. And I just wanted to leave you with some vaccine facts, that they work, they're safe, they really decrease the emergence of variants, they can help us speed up safe reopening, and they also protect our most vulnerable in our communities. So with that, I'm just going to stop, and I look forward to your questions.
We're not going to let you run away that easily.
No, that's fine.
That's one of the most important things, though, isn't it? I mean, I'm a huge advocate of getting the vaccine done. I've had both of my vaccine doses now, and I've started volunteering at a vaccination centre, just stewarding and sort of helping out there as much as I can. And yet, when I posted this on social media, I was faced with a slew of anti-vaxxer trolling. Not from my followers, but from people who seem to be going around the internet trying to find people who are trying to promote the use of the vaccinations and try to pour all sorts of damaging misinformation on top of it. And it was really quite distressing to see that. So are you able to give any insight or sort of information to people who may be worried about, particularly with the recent emergence of the news with the AstraZeneca? I've had the AstraZeneca vaccine, both doses, and I'm absolutely fine. And I know, of course, the vast majority of people are, but are you able to reassure people?
Absolutely, Nathan. I think, we know that we have a lot of data telling us that vaccines are safe and they are effective. As you said before, I know we have gone from identifying the virus to vaccines in a super, time within the last year, but we haven't cut corners, right? They've still been through a very rigorous process of going through clinical trials, preclinical studies, smaller clinical phase 1, phase 2, phase 3 trials to ensure that they are safe. So we have no concerns about the safety of the vaccines, and we know that they work. And you could argue that I am biased as an immunologist, but they are safe, they work, and it's really our way out of this pandemic.
I couldn't agree more. I think it's for me the reassuring thing. Yes, it's been frightening to see that there's been the emergence of the hemorrhaging and blood clotting problems, but I've been looking at the numbers and trying to see the numbers that of people in the general population who have not had this vaccine, who suffer from the same sorts of problems, and comparing the two. Is it still the case that the number of problems from people who have had the AstraZeneca vaccine are still lower or comparable to what you'd expect to see in the general population?
Absolutely. So to try and put this into a bit of context, right? I know that the AstraZeneca, there's been a lot of publicity about sort of blood clotting side effects, and quite rightly, this has been thoroughly investigated, and that's why we have all the regulatory committees in place to ensure that any of these things that are kind of flagged up are properly investigated to ensure, vaccine safety. So to put it into context, this is sort of the rare thrombotic events in the context of the adenovirus vector vaccines, such as the AstraZeneca vaccine, 4 cases in a million vaccines, right? So the percentage is extremely low. If you look at that put it into context, into females that take the birth control pill or people who smoke, this is a fraction of the risk. And then if you look at it into the context of somebody becoming unwell with COVID infection, your risk goes from up to 16.5%, right? So your risk of getting a clot from the vaccine is 0.00 some 4. And then your risk of getting a fatal clot having had a COVID infection is, much higher than that.
Yes.
And then if you smoke, it's much higher than that. So your overall risk of having a clot from the vaccine is a risk-benefit decision, right? So and I think people need to view it like that.
That's
no medication.
Information, really, because I hadn't realised that COVID itself. Obviously, I knew there are other risks to one's health from COVID. I didn't realise that COVID also has a risk of clotting, which is a far greater risk.
Absolutely, yeah. It's an intriguing virus in the sense that it causes a sort of a very interesting sort of clotting abnormalities, and we see a lot of what we call thrombotic events, or microclots or microthrombi that are scattered throughout the body. So it does increase your risk of getting clots, and as I said, a lot of other medications do, and a lot of habits such as smoking can also increase your risk. So I think we need to view that in the context of benefit and risk. If you ask me what vaccine I had, well, I had the one that I was given. I was given AstraZeneca vaccine, and I said, yes, please give it to me, and thank you. And I have similar discussions with family members, and and I discuss very openly all of these potential risks and benefits from a vaccine. And I think we need to frame that and put it into context.
I'm exactly the same. I was so grateful for mine, and it felt like the start of an optimistic future. It really did. It was actually a very moving experience. My first jab was something I became quite emotional afterwards, and even with the risks that are being reported and misreported in the press and certainly on social media, I am so convinced, reading everything, hearing you talking today, that me as a person living with HIV today, the best thing I can do is take whatever vaccine I am offered.
Yeah. I couldn't advocate for vaccines anymore. And I think now it's particularly important because of the circulation of a lot of the sort of the variants, or what is a variant. And, SARS-CoV-2 is an RNA virus, and every time it multiplies, it changes. So, and we call that change a mutation, and that leads to the various variants that we have circulating in the community at the moment. And we know that vaccines work, but we also know that they work against the variants. They may not work as well as the original strain of the virus, but we know that they still have some level of efficacy against the variants. So if it is an option of getting COVID and severe disease and having a vaccine, I would say have the vaccine.
And I think that's really important as well, to contextualize what the vaccine is for. Yes, we know that the vaccine does reduce the risk of catching COVID, but it doesn't stop it. But that's not what it's designed to do either. It's designed to stop people from being hospitalized and from dying for it. And it is very, very, very successful at doing both of those things. So yes, you will probably hear of people who have been vaccinated and have then gone on to catch COVID-19. That's not to say that the vaccine's not doing its job. I will hazard a guess to say that it's stopped them from needing to go to hospital, and that's what's important.
And I think you raise a very important point there, Nathan, that this is how, the vaccine it was not designed to, prevent disease. I mean, yes, great. We know that it can also, in some cases, some of the vaccines that we have available can also reduce transmission, great. But the aim of the vaccine primarily is to stop people from dying and getting severe complications. And the current vaccines that we have available to us are very good at doing that. So even if you get a disease, it will be in most cases mild disease and not a fatal case. And I think that is the important when we look at the vaccine. Yes, the ideal is to have that sort of the full 100%, asymptomatic disease, no transmission. But actually, if we have less severe disease, that is fantastic.
Absolutely. So we've got a few questions coming in. One from our fellow panelist as well, who's sitting helping us in the background. And she says, does the vaccine also help with boosting general immunity beyond COVID at all, with other viruses like flu or anything like that? Or is it only specific to that one thing? So a lot of people don't really understand quite how these things play with each other.
Yeah, no, we don't know the answer to that. I mean, the vaccine, the COVID-19 vaccine is very specific to the SARS-CoV-2 virus, the spike protein. We have no evidence at the moment to suggest that it does anything else beyond that. But I think that's a very good pertinent question to see what would be the interplay between various vaccines and whether you have a COVID-19 vaccine and then you have a flu vaccine, let's just say, down the line, whether there's going to be an interplay between the two. But they are designed very specifically to boost immunity to SARS-CoV-2 infection rather than interact with anything else, just because of the way they're made.
Coronaviruses, but I was listening to a talk earlier on today, which was talking about the mRNA. Which is, for anyone who doesn't know what that is, the mRNA vaccines are the ones that use a particular method of transporting the little bits that they're trying to get the immune system to talk to and respond to into our bodies. But it's so even though mRNA is a very, very well designed system and it works incredibly well, the tricky thing is finding the very specific protein that will provoke the right kind of immune response for that particular disease, and that's the bit that's tricky to find. So am I right in saying then that every single type of vaccine, it has to be tailored so uniquely to do that one very specific job, otherwise it's not going to be efficient for other types of illnesses? Is that correct?
So yeah, so the mRNA vaccines work exactly like that. And I think in sort of in lay terms, you can think about giving your body a blueprint of the sort of providing the message for your cells to start producing the spike protein, specifically, a subunit of your spike protein, so that your body starts producing antibodies against that. And this is kind of a message that self-destructs, right? So it doesn't incorporate anywhere else in your body. So it's very specific to that. But I guess sometimes with vaccines, you can have a bit of a sort of a reaction to it, kind of generically, that can sort of influence, pre-existing responses to other things. We don't expect it that it would work, that it will, induce a kind of a flu response, because you haven't instructed your body, if you wish, to just make a response against the flu protein. Sure. Right? It's very specific to the SARS-CoV-2.
We've got another question come in. In your opinion, is there one particular vaccine which might be better suited to people living with HIV over the others, or are they all doing exactly the same job? Because based on the data you've said, there's just not really much difference between HIV positive and negative across the board, apart from with those certain caveats of different comorbidities and things.
Yeah, I mean, at the moment, Nathan, we don't have any evidence to suggest that one vaccine is better than the other vaccine in the setting of HIV infection. So we advise people, as long as they don't have any specific contraindication to the vaccine, to have whichever one they're offered. Right. So we have no evidence to at the moment suggest that one vaccine may work better in the setting of HIV versus another one. We just don't have this data available. And I think one has to be very careful when we look at vaccine efficacy between vaccines, right? We can't compare one vaccine to the other vaccine. unless we design a trial that is designed to do that.
Yes.
So I think one has to be very careful, because, a lot of people say, oh, the Pfizer, the Moderna is 90%, 94, 95%, the AstraZeneca is 70 odd percent. I wouldn't compare vaccines like that, because the trials were not designed to do that. They were done.
If you wouldn't mind, I'd love you to contextualize that even further. What's the percentage for the annual flu vaccination
Oh,
that we
60%.
take every year?
60%, right?
So this is already better than something that we've been happily taking years and years and years.
Yeah, it's unprecedented. We've never had a vaccine that works at that level.
I mean, I think those are the facts and figures that really make a difference to people, because they hear these percentages and go, oh, well, if it's only 70%, then that's not very good. It's well above the threshold of useful that we deal with all the time.
Yeah, it's astounding. We've never had a vaccine to that extent. So anything above 60 is fantastic.
There's a HIV funding question that's in the Q&A. Are we still getting the investment and the grants that we need to improve research? I know it's obviously never going to be enough, but have resources been diverted away from HIV research in the past year or so?
Yeah, I think what is true is that resources, sort of funding resources, are limited overall, and I think a lot of things that have happened over the last 12 years have not really helped. A lot of the funding has been diverted more into COVID-related research, and to an extent that is understandable. But even now, the funds for even COVID work are drying up, and that's sort of reflecting of the funding situation in the UK. The work that we have performed, we really didn't have any specific funding for that. We managed to get a little bit of sort of an extension sort of fund to be able to do this work, but it was largely done by PhD students, DPhil students, who did the work out of hours because they're really truly interested in doing and committed into doing this work. And we are in the process now of trying to fund more work into COVID-19 immune responses in the setting of HIV, but also other immunosuppressive conditions, so we can have another level of sort of comparison. And this is people with different types of blood cancer, so different levels, so we can have groups of people with different levels of potentially immunosuppressive conditions, if you wish. And we are putting an application forward to be able to fund this work. But I think overall funding is changing. A lot of funds have been diverted away, as you know, from more general HIV-related work, which is a disaster. But at a sort of global level, but that is the current reality. And I spend a lot of time trying to think about this and trying to come up with the resources to be able to do this work.
Do keep your questions coming in on the chat. We've still got about 20 minutes to go. I've got lots of other things that I can ask Dimitra in the meantime while we've got some coming through. One of the things I'd like to talk to you about are the things that are not COVID related. What are the other types of HIV specific study programs that are happening now at the Mortimer Market Centre, or are likely to be starting soon and might need enrolment?
So one study that I want to highlight is not a Mortimer Market, it's at the Royal Free Hospital. It's a seroprevalence, COVID-19 seroprevalence study. That's the SCAPE study that is currently sort of enrolling people attending their service. I know it's a different service, but feel free to kind of disseminate it to people attending that particular service. I think a lot of the activity for research studies is now picking up at Mortimer sort of lots of sort of exciting stuff. From a more sort of I can sort of give you more details at the more sort of immunological sort of based type of work, the more lab-based related work. So there's a lot of the hepatitis and Hep B HIV co-infection study that has been recruiting for kind of many years. And for the more sort of clinical related studies, I don't have that information sort of handy. I can find it out for you and forward it to you.
Do you, if there's anybody who's listening tonight who might be interested in volunteering their services in the subject, who should they contact and what's the best way to go about it?
So, I got the list with about the currently recruiting study. Sorry, Nathan, can you repeat your last question?
Yeah, I was just going to say, if there's anybody attending this webinar now who suddenly thinks, I would like to take part and help out with some of these research studies, who is there somebody like a central contact for that kind of thing, or should they just talk to their HIV clinician next time they're in the clinic?
Yeah, so they can do that. They can chat to their HIV physician, but if they're particularly interested in taking part into the COVID-related studies, because these are live, because vaccination has one of the good things about the vaccine program is that the rollout has been, really impressive and really, really quick. So if somebody is particularly interested in finding more about these studies into COVID-related immunity, they can call up the clinic and they can register their interest at reception. So there is a dedicated list, a work list that we scan on a daily basis. The research team scans on a daily basis. So they can identify potentially people who may be interested. There's no so somebody can contact for more information. That doesn't mean that we're going to hold them to that. We're always happy to provide more info. And if they're still interested, then we can make arrangements for them to come in and donate a blood sample at a convenient time point. Right. So that would be one way of doing it. The other way would be through contacting or through their regular physician who will be able to direct them to us. So that would be another way of doing that.
I've got one question come through as well. Within the two groups of people that have been researched that we were talking about earlier, the hospitalised and those people who are not, has anything been done on trying to look at their outlook and positive mental attitude and sort of the psychological mechanisms of recovery as well and things like that? The person who's asking the question said they've had COVID twice. Their CD4 count has not been above a fairly low level in 20 years, and he or she is quite sure that it was their mentality to fight and get through it and the use of natural remedies and being kind and gentle to themselves, but they are left with some sort of breathing issues, although the second time was a lot easier. So there's a lot to pick out of there, but obviously we've seen lots of information about a second infection. Rare, but it does happen and often is a lot easier than a first infection. Do you think that's partly to do with the immune responses, or can it also be to do with a positive mental attitude?
Yeah, so you're right. There are lots of sort of things there. So if we start with the overall impact of the pandemic, not just on the kind of in terms of physical symptoms, but in terms of, the kind of the psychological impact of the pandemic, we can't underestimate that. We often concentrate on the physical signs because it's easier to concentrate on that. But we have been looking, as you know, on the potential psychological impact of the pandemic. So along with research samples, we do questionnaires where we can try and gain a little bit of insight as to how the pandemic may have affected people in different ways, including, doing a sort of an anxiety scale sort of questionnaire to get an idea of, how severe that impact may be for some people, but also to gain some insight on coping strategies. And, people have coped with this pandemic in different ways during the various periods of lockdowns. Now, does your mental well-being influence your kind of immune responses? Well, I think it's important that we kind of look at it from the point of view that if you feel physically well and you look after yourself and you look after your body, and and you're in a good sort of state, I think that's important. That helps. Now, do I think that this is the reason why somebody may have become reinfected, just purely because of the, potentially low mood or psychological? I think it's unlikely. I think the most likely explanation in this case was that any responses from the first infection may have waned, and because we know that they last for a good 6 months, but then these responses, and they will go down with a period of time, and this particular individual may then have become more susceptible to being reinfected again, because the responses from the original infection may have gone down or may have waned to a level where they were not protective anymore. But the fact that there are still some very low level memory responses, that may explain why the second time the disease wasn't as severe. Another potential explanation to that was that they may have been exposed to a different type of the virus, to a variant perhaps, where the original immune responses may have not been as protective against the new variant, but nonetheless offered a degree of protection. So I think that's the most likely explanation, but I think we cannot underestimate the psychological impact of the pandemic, how that affects the way we are, and and that's important.
I think that's definitely true. I mean, because we know that things like anxiety and stress and all kinds of psychological things have a real physical impact on our health anyway.
Yeah, for
So
sure.
to make sure that you are keeping yourself calm and being kind to yourself, if that's massages where it's possible these days, or just make long walks in the country, all of these things are bound to help in some way, aren't they?
Yeah, for sure. And I think we really underestimate. And I think if it's anything to take out of that, is just being kind, and being kind to ourselves. It's been a tough 12 months for
Yes.
everybody. And it's been a hard slog for all of us. And it's completely sympathize with everybody feeling really fed up. And I know where now the restrictions have been lifted, but I would still exercise caution.
I think that's a really important thing to mention as well. We do need to we really do need to continue to be vigilant, optimistic, yes, and grateful for the relaxations where we can, but still not believe that it's all gone away. And we've got a couple more questions. Sorry to jump straight in on you,
Yeah.
and I want to get through these in the next few minutes as well. How has PrEP affected your work? Has PrEP made clinical studies harder to monitor results?
No, it hasn't. So I think it's great, actually. And I think that's a fantastic, I think PrEP has been one of these fantastic things that have happened, right? That's fantastic achievement. It hasn't really influenced our work, because I think over the years, with the focus of the research has turned more into chronic HIV infection, and really how to deal with chronic inflammation, aging, and a lot of other medical conditions that arise in the context of HIV infection. So the focus of our research has kind of slightly changed a little bit. Yeah, no, PrEP hasn't. It's a fantastic thing that has happened in the field of HIV infection. So yeah, we
It's
need more of
one
it.
of the main reasons why we're seeing such a lessening of new infection rates, isn't it? Obviously, with better testing and all
Yeah,
sorts of better information. But I think PrEP is certainly one of the strongest tools in our armory.
absolutely, absolutely.
And talking of tools in our armory, we've got a question about the new Cabenuva drug, which is cabotegravir and something else, I forget which is one of the long-acting
Yeah.
injectables. What do we know about that, and will we be getting it here anytime soon? I know it's been passed for FDA.
Well, not quite yet, but I think there is light at the. I think this is really exciting. I think we're not quite there yet, but for me, I think that's been one of the exciting things that have come out.
Mm.
been highlighted, really nice data. So I think there's lots of excitement. We're not quite there yet,
I
but
think I think it'll be a bit of a game changer for a lot of people who struggle with adherence, and people for various reasons don't want to be taking tablets every day because it's a constant reminder of their status when they might want to just sort of forget about it. I have a friend who is she's a neighbour, but she spends a lot of her time on the streets asking people for money because she's essentially homeless. And I know she has HIV and she wasn't taking her meds for a very, very long time, and that was one of the reasons. It was a barrier to her for staying connected to the care that she so badly needs, and it was really starting to affect her health, and things were getting quite advanced for her. But I saw her today, and she's looking brilliant. And I said, I said, you look great. And she said, I'm back on my meds. And of course, that was such a wonderful thing for me to hear, which was fantastic.
it,
I think for somebody in her situation, a 6-monthly injectable will be an absolute game changer.
it would be, I agree. And I think it really also highlights, even though